like, are you done with the Skittles? And I'm like, yes, you can have them.
Well, I noticed in some of the results that you got for the red, they were small amount.
Yeah, it's funny because, you know, like we were talking about with the Hershey bars having different weights, there were actually different amounts in each bag. I mean, they were about the same, but they were different. And the colors were the same way. Some would have less, some would have a lot more. So it'll be interesting to see how it turns out when all of ours are together. So
right.
I can definitely see how more data makes better, you know, numbers.
Yeah.
So yeah, so I figure if we all key in on that, you guys could send it back to me. And then there's a little spreadsheet that we have to do this week, but it's not a big thing. But I think, again, one person just sends in, like, the group, collect the data. So.
Okay, and we said that I was going to be in charge of that part, right?
Are you on collect the data or determine the data? I don't.
I thought I was on collect.
Okay.
Then.
Awesome. Then we'll be sending it to you.
Sounds good. Okay. Here. Alrighty. It took me like 4.5 hours to do our exam review, the individual preparation.
But yours is thorough then. That's good.
Yeah, but I worked on it with my tutor friend. So, like, if I had any questions, she was kind of like, she sat there next to me with like just playing on game on her phone. If I had any questions, she'd be like, hey, what does this mean? And so it was relatively.
Can you have her on when you have your test? Have her on the side. Hey, I need this.
I was super bummed because I did the same thing with the last test, and like I did really well in like the practice review. But when I went to like take the actual test, I opened it, and all of the questions were worded so differently. It was super confusing. I was just like, this doesn't make any sense. I suppose it was all the practice test.
Right.
But he has a little disclaimer at the top that said, "Oh, some things that you review on this practice exam will not be on the regular exam, and some things on the regular exam will not be on this practice exam." It's like, thanks.
It's very tricky.
I just find myself second guessing myself, and that hurts because then you're not sure what you did. And then you say, well, maybe I didn't do it right.
Right.
And that's gotten me in trouble.
I wish we got a second time, like with the quizzes, you know, if I could just have a second try so that if I wasn't sure about it, I could go this. Oh no, that one didn't work. So how about this? You know,
Yep.
Gives me a chance to kind of, you know, but I guess that wouldn't be fair for an exam. But should we start the quiz? And
let's go for it.
How are you?
All right, we got a problem here. "45 questions. Ooh, yeah.
I think it's mainly just because like on the practice one, it's 38, but it like kind of like lumps them all together. Like sometimes it says just give like everything in one, so like the margin of error and the upper and lower bound. Down. And so I think that's why it kind of expanded it a little bit. Sorry. Alrighty. You guys want me to take the first question? Or question number 2?
Sure.
Okay, so in an article in the Journal of Small Business Management, successful startup businesses in the United States and Korea were compared. One set of data compared education level, high school, undergrad, master's, and doctoral of people who managed successful startup companies in the United States and Korea. You want to determine if education level of managers of successful startup companies is independent of the country they are from. Which hypothesis test would be most appropriate for this analysis? So since it specifies independent, I think it's the chi-squared test, right?
I do too. That's what I put. And because it seems like it's comparing not numerical, categorical data. We're talking about like the success of. That was the reason, but like I agree, these were really tricky though, so
Yeah.
So it'll be fun to see what they say. Do you want me to take the next one?
Yep.
Okay. So question 3, a human resources manager reported data from a recent involuntary reduction in force at our company. You are an attorney and want to determine if age discrimination was a factor. It's illegal to discriminate against employees because of age. The company reported the number of employees in 2 groups, 40 years old or younger and over 40 years old. They also reported the number of employees in each group who were terminated. You want to determine if both age groups were treated equally. Which hypothesis test would be most appropriate for this analysis? And I put test of 2 proportions.
That's what I had. Test of 2 proportions.
Yep, that's what I have.
Is that what everyone did? Okay. I mean, I say that with a question mark because these were all very tricky to me.
Okay. And okay, so next question, wait a minute. Okay, a bank employee employs two appraisers. When approving borrowers for mortgages, it is imperative that the appraisers value the same types of properties consistently. To make sure this is the case, the bank evaluates 6 properties that both appraisers have recently valued. Which confidence interval will be most appropriate for this study? And confidence interval for 1 proportion?
Yeah, that's what I did.
I got the paired samples just because, like, if you have the 2 appraisers, they're dependent of each other, because if one appraiser has to appraise then house A, and then appraiser 2 also has to appraise house A, just to make sure that they're consistent. That's why I said the paired samples.
That is 152.
Let me double check.
You want to determine if the proportion of males is different than the proportion of males in the population. Is that what we're on? Am I reading the wrong one?
This
it's the bank appraisers, right? Is that what you guys were talking about?
That's the one we're talking about, bank appraisers, right?
That's number 6, right? Or did we skip some?
I think we skipped number 4.
Oh, we did? Oh, well, then you know what? Okay, I'm sorry.
Why we have
no, you know what? My thing moved so much, so I just went with that one. Okay, so I'm sorry. Let's go back.
Okay,
number
I just
3. So we're up to number 3. No, we already did 3.
Number 3 was the test of 2 proportions, right?
Okay, so I jumped. Mine jumped so much. Okay, test of 2 proportions. That was number 3.
Yes.
Okay. So a survey was conducted by a group of state lotteries. A random sample of 2,406 adults completed the survey. A total of 248 were classified as heavy players. Of these, 152 were male. You want to determine if the proportion of male heavy lottery players is different than the proportion of males in the population, which is 48.5%. Which hypothesis test would be most appropriate for this analysis? And now 4, paired sample test, t-test.
Number 4?
Yeah.
So that's the one I have, test of 1 proportion.
Yeah, that's
test.
the one I have plus 1 proportion.
Oh, okay. So,
Okay.
So my tutor said, like, for this, like, it's best to just look for, like, keywords. So if you see, like, the word proportion or percentage, like, in the question,
okay.
then it's going to automatically be either 1 or 2 proportions. And then if it's taking from one sample,
Yeah.
then, yeah.
Okay.
All right. So test of 1 proportion. Okay. Okay. I froze. So.
Oh.
If you want to continue, so that way you don't have to wait till I get this thing.
Okay, I can take the next one. So a student project compared the effectiveness of 2 different combination locks. One of the locks turned clockwise first and the other lock turned counterclockwise first. They asked 25 students to participate in the study. Each student was given the combination to each lock and asked to open the locks. The time it took them to open each lock was recorded. They want to determine if one of the locks is easier to open. Which hypothesis test would be the most appropriate for this analysis?
There's your paired samples.
Yeah.
Mm-hmm.
Right? Okay. Yeah, that makes sense why we were off.
Off, right. 3.
Is yours back working yet, Juan?
No. Okay, I'm gonna reconnect right now.
Charlie, knock it off. Charlie.
Okay, I'm back.
He's back.
So
we're on number 6. You want me to take that one?
Just to go over again, question 3, it was test of 2 proportions, right?
Test of proportions.
Of 2 proportions, right?
Right.
Okay, then 4 was the
test of 1.
Test of 1 proportion, okay. And then 5 was the paired sample.
Mm-hmm.
Yes, okay.
So for number 6, it says a bank employs 2 appraisers. When approving borrowers for mortgages, it is imperative that the appraisers value the same types of properties consistently. To make sure that this is the case, the bank evaluates 6 properties that both appraisers recently valued. Which confidence interval would be most appropriate for the study? And that would be the paired samples.
The paired samples T confidence.
Uh-huh.
Mm-hmm.
Okay.
This is what I have, yeah.
Paired samples T confidence interval.
Number 7.
Okay, so that was 6 there.
Mm-hmm.
Did I miss something? 6. Okay, 7. All right, I'll take 7. In a Wall Street Journal article on satisfaction with career paths, the percentage of psychology majors reporting they were satisfied with their career path was reported. The same data was also reported for accounting majors. You decide to construct a 95% confidence interval to see if the observed difference is significant. Which confidence interval would be most appropriate for this study? The percentage. Okay, so we're comparing percentages of psychology reporting they were satisfied with their counting majors. It's a difference, right?
It has the key word for the proportion again, so it has percentage in it.
Okay. So then it has
the interval for two proportions.
And that's what I put. I put that also because we're comparing the satisfaction. I love how they have it even in quotes. Because like, how do you rate satisfaction? You know.
So if it has percentage, that's a clue that it's going to be the proportion.
Mm-hmm.
Okay, that's good to know.
So confidence interval for 2.
Okay. All right, and I am stuck again. Why? Okay. Okay, I'm back. So 7 was confidence for 2. All right, so we're up to 8.
Mm-hmm.
Right. Who wants to go?
Number 8, right?
Yeah.
Okay, so double stuffed Oreo cookies are supposed to have twice the filling of regular Oreo cookies. You and some friends decide you want to know if that is a true assertion by the company who makes them. Take a sample of 55 double stuffed Oreo cookies and measure the amount of filling in each one. You need to construct a confidence interval to estimate the true mean filling amount of double stuffed Oreos in order to compare it to the filling amount in regular Oreos. Which confidence interval would be most appropriate for this study? I think it's the one sample T confidence interval because it's only because only talking about the double stuffed Oreos, and then we don't have the standard deviation isn't given, so it wouldn't be a Z confidence interval.
Right.
Okay.
Yep, that's what I put.
One sample T confidence interval.
Who wants to take number 9?
I'll take it. Which one of the following best defines the notion of the significance level of a hypothesis test? The probability of observing a sample statistic more extreme. No. The probability of type 1 error. Probability of rejecting HO, whether it's true or not. And the probability of type 2 error. I'd say it's the probability of the type 1 error.
Yep.
That's what I got.
Okay.
I'll take number 10 then. Which of the following best defines the notion of the p-value of a hypothesis test? The probability of a type 1, the probability of a type 2, the probability of observing a sample statistic more extreme than the one actually obtained, assuming the null hypothesis is true. And that's the one I picked, that third choice.
Yeah.
Number 11. Suppose you create a 95% confidence interval for a mean and get 10 and 20. You've been told to report this by saying something like, we are 5% confident that the true mean is between 10 and 20. Exactly what does this mean? 95% of all the sample means are between 10 and 20. 95% of all 95% confidence intervals actually contain the true mean, which is the one that I put.
Yes.
That's
what I have.
Okay.
awesome.
Okay, use the following information to answer the next 3 questions. You take a simple random sample of 100 adults from a town in the western United States to determine the proportion of those in town who invest in the stock market. Assume the unknown population proportion of percentage of people in town who invest in the stock market is P equals 0.30 or 30%. What is the mean of the distribution of sample proportions?
And that one would just be the 0.30, right?
Yeah.
0.30, that's what I have, yeah.
Yeah, that's what I have.
What is the standard deviation of the distribution of the sample proportions? And I have 0.046.
Yep.
Yep.
We got.
Yeah.
This is good.
They're like exactly the same questions.
Right, and practice, right.
It's in another order.
Yeah, except for the very first one. On the actual practice one, I got independent sample because it was worded differently, and then on the test itself here, it was the chi-squared.
Yeah.
Yes.
Like
Okay.
deviation I've seen so far. Okay, so what is the probability that your random sample of 100 adults will have a sample proportion less than 0.25? So with the little the applet guy, I got 0.138.
Yep.
Okay, can you go over that, how you got that?
Yeah. So once you find your z-score, you take the proportion, which is the 0.25.
Yes.
Which gives you that in the question, and you subtract the mean, so the 0.30, and then use the standard deviation you got from that last question, so the 0.046, and you divide by that, and so it gives you a z-score of -1.087, and then you put that into a little applet guy, and then you shade only to the left. So you leave the middle and the right wing unshaded, and then it'll give you, for the little area guy, it'll say 0.13. I think like 7, and then just round it to 1.138.
Great.
So it's the sample proportion minus the sample mean over the standard deviation.
Okay. Thank you. Okay.
This one is the one where we use our little the Excel categorical data analysis thing, right?
Right.
Yeah, that thing was probably my best friend that I have recently discovered.
Yes, I completely agree.
It was beautiful. Like, I think it's funny, like sometimes the tests are a little difficult, but if you know how to like use the tools that he gives us, like the Excel or the SPSS, it gives us the answers.
Yeah.
And I love it. Okay.
Okay, so the first one, what is the margin of error for this 95% confidence interval? I had, hold on, let me see. I had the in paren minus 0.003, the lower bound, and then 0.029, the upper bound. Okay.
And then for the actual margin of error, it was the 0.016, right?
6, yeah, that's what I have.
Yeah, I'm sorry, I went ahead. It was that one, right? Okay.
So margin of 0.016.
0.
Or negative 0.003. And then upper 0.029. And I don't know if I already told you this, Chase, because I really fell in love with that Excel spreadsheet as well. And I double checked with the teacher, and we can use it on the exams and everything. Like, not just.
That's just lovely to hear.
Isn't it? I was like, yay! Because even if you calculate it out, at least you would have like a double check if you want it. You know what I mean? Like,
yeah,
it helps me feel like I'm on the right track. So we've got 16 and 17. So we're on to 18. I'll take that one if you want. We perform a hypothesis test to see if a proportion of experimental group subjects who experience dizziness is different than the proportion of control group subjects who do. Use level of significance, alpha equals 0.05. What are the appropriate null and alternative hypothesis? And I have P1 equals P2 for the null and P1 not equal to P2. So that very first one is what I have.
Yep, that's what I have.
Okay.
For the values test statistic, I got 1.458.
Yeah.
That's what I have.
458.
And the p-value is 0.145?
Yep.
Okay.
So the next one, is there sufficient evidence to conclude that the true proportion of people who experience dizziness while taking Acupril is different than the true proportion of people who experience dizziness while not taking? So if we look at our little significant facts, 0.05. So since it's greater than 0.05, we failed to reject the null hypothesis. So it would be the fourth one, yes, there is sufficient evidence because I failed to reject the null.
Right. Failed to reject.
Wait a second. Is there sufficient evidence to conclude the true proportion of people who experience dizziness?
It would be no, right? No, failed to reject?
Yeah, it would be no, I failed to reject. Okay.
So the last.
Right,
okay, yeah.
That one was tricky for me because I'm like, I know I fail, but what is it, yes or no, is the part that I was like, oh. All right.
Yeah. So, yeah, I completely forgot my, so, where was it? So fail to reject is always going to mean insufficient evidence.
Right.
That's what I always forget. Yeah, okay.
Yeah. It seems backwards almost, the way it's worded.
Okay.
So for number, go ahead.
Oh, okay. A survey was conducted of 1,279 randomly selected adults age 18 and older They were asked, are you a morning person or a night person? The hypotheses for this study are HO, being a morning or evening person, is independent of age. HA, being a morning or evening person, is not independent of age. The results of the survey are given here, and then they have the numbers. Conduct a test of independence. Use a level of significance of alpha equals 0.05. 22, calculate the test statistic for this hypothesis test. Assume the requirements for the test are satisfied. And I have 6.580.
Oh, I got 6.579.
That's what I got, because I don't think we're supposed to round it to the second one, so I think we have to leave it as a 6.579.
Okay.
Oh, okay. Oh, great. I'm out again.
Oh, no.
All right. So 22, let me just write that down so I can come back. 22 was 6.579, right? Okay. All right.
And then for the P, I got for 23, 0.087. Is that what anyone else got?
That's what I got.
Hold on. Yeah, 0.087, right.
Awesome.
All right.
Okay,
Okay,
so
24 now. Back up.
okay, so should you reject the null hypothesis or not? Explain. We do not reject because the p-value is greater than 0.05.
Yeah.
Yeah.
So then for 25, we would have insufficient evidence to say that being a morning or evening person is independent of age. The third answer is what I have.
Is it independent or not independent? Because the null hypothesis is that they are.
Oh, you're right. Yes. Last one. Thank you. Sufficient.
So we have insufficient evidence to say, right, that being a morning person is not independent.
Is not independent.
Right. Okay.
That is 25.
Okay.
A recent book noted that only 20% of all investment managers outperform the Dow Jones Industrial Average over a 5-year period. A random sample of 200 investment managers that have graduated from one of the top 10 business programs in the country followed over a 5-year period. 50 of these outperformed the Dow Jones Industrial Average. Let P be the true proportion of investment managers who graduate from one of the top 10 business programs who outperformed the Dow Jones over a 5-year period. Create a 95% interval of P and put the lower and upper bounds. So for 26 for the lower, I got 0.190.
That's what I got.
Yep. And the higher is 0.310.
Yep.
Okay.
And then we had the crazy Z star over M squared P star times 1 minus P star for the next one.
Yes. So I got 1537.
Yep, that's what I got.
Okay. 1537. That's what it is. Okay. So suppose you wish to see if there is evidence that graduates of one of the top 10 business programs performs better than other investment managers. Conduct a hypothesis test. Use a level of significance of alpha equals 0.05. Which of the following pairs of hypotheses is the most appropriate for addressing this question? And I had the HOP equals 0.2 and the HAP is greater than 0.2.
Yep.
That's what I got.
That's the number, second to last, right? Yeah.
Mm-hmm. And then for 30, what requirements must be met to ensure that P hat is normally distributed? I have that first one, NP greater equal to 10, and N times 1 minus P is greater than equal to 10.
Yep.
That's what I got.
So,
Okay.
For the test statistic value for number 31, I got the 1.768.
yes.
Okay.
We have 0.03. Do we round that up to a 9? 0.039?
That's what I did, yeah.
Yes.
Okay.
Okay.
Awesome.
Okay. Is there sufficient evidence to conclude that that graduates from the top 10 business program perform better than other investment managers? Okay, I put yes. I rejected the HO.
Yep.
Okay. So now we're going to the blue score thing.
Mm-hmm.
So assuming the requirements are satisfied, construct a 95% confidence interval for Farrah's true mean for the blue score. Record your answers. So for this guy, for the lower bound, I had the 0.282.
Yep, that's what I have.
282.
And then for the upper, 0.293.
Yep.
1 second. I think I'm stuck. Oh.
Okay.
1.282. And then for the higher one is 0.293. 3.
Yeah.
Okay. Okay. Calculate the degrees of freedom, the test statistic, and the p-value for the test of HO mu equals 0.295 against the HA, 0.295, not 0.2. Assume the requirements are satisfied. Input your answer to the next 3 questions. Input the degrees of freedom, and that one I had 99.
I did.
And the test statistic. Put the test statistic on 3 decimals.
Negative 2.803.
Negative 2.803.
Awesome. Some of these numbers look crazy, so I'm always like, oh, I don't know.
Yeah. Well, when I first did it, I forgot to change the test value when pulling it up on the little descriptive box.
Oh, uh-huh.
Use the test from 0 to the 0.295, and so I got like a really crazy answer.
Yeah, I was kind of glad he stuck this one in the review because I did the same thing at first, right? I left it at 0 because the whatever, the independent samples one doesn't require us to change it. So I was so used to leaving that I had to go back and put that, and then I'm like, oh, okay, that looks better. So then the p-value of 0.006 is what I have.
That's what I have.
Okay, that was 38.
6.
Oh my gosh, we're almost done.
Okay, so for the next one, based on the results of this test, what would you conclude using a level of significance of 0.05? So I said there is insufficient evidence to say that the true mean is different than 0.295.
Oh, I said we have sufficient evidence.
That's what I put down. We have sufficient evidence.
True mean is different than point. So that first one is what, right?
Yep.
Yeah.
Okay. Okay, the next 6 questions have to do the AM PM heights. And we want to determine if the children are taller in the morning and evening. Define the difference as AM height minus PM height, which I love when they include that. Construct a 95% confidence interval for the true mean difference of heights and conduct a hypothesis test at a level of significance alpha equals 0.05 to determine if the children are taller in the morning than in the evening, and input your answers. So for my lower bound, I have 8.728.
Yes, all right, I got that.
It's really high, you know what I mean, for one of these, so I was really surprised. 8.728, and then my upper as 10.455.
Yes.
That's what I got.
And then for the other, hopefully this is right. For the T, did you get a high number of 22.446?
I did.
You did? Okay.
That's what I got.
Okay. So I wasn't like, wow, man, I'm off.
I know, it seems like it, doesn't it? Such high numbers.
And
Okay,
then
so
the freedom, 40? Okay.
Yeah.
And then for the p-value, 0.000.
That's what I have, 0.
Yes.
All right.
Okay, and then based on your results of this test, is there enough evidence to suggest that children are taller in the morning than in the evening? And then I said yes, because we rejected the null.
Yes.
Right.
Okay.
Okay. Wow. Oh, 40. 40, did I say that? Yes.
45.
40.
You got 100.
Woohoo! Now if we can get 100 on our exam, I'll be thrilled.
That would be fantastic.
I'll be happy with like a C, and if I get like a B, I'll probably have like a heart attack from the shock. So
It sounds like you're gonna do really well though, Chase.
I'm hoping so. I'm just like, I spent like within the past few weeks, I spent like I think 16 hours with my tutor. So I'm hoping that I'll like.
That's great. You're getting a lot of help there.
Yeah, that is great.
Thank you so much, both of you, helping out. There's still things I need to review, but it's coming along. It's getting there.
Yeah, I took a lot of notes like during my tutor thing today. So like when I go through and make my 1-page note thing, I'll be able to like help myself more.
Okay. Okay, so let me
That's
check.
really good. So you're ready to take the test just about then, right?
Yeah, it's like it's finding the time to do it. I work 2 jobs during the day, so I'm just like, I like it better when the test ends on a Saturday because it's just so much easier for me to like, because I only usually work at one place on Saturday because my other place is closed.
Mhm.
So,
Imagine that would be hard. See, I wait until late at night when my kids are in bed. Then I take it because I'm like, I need to not be interrupted. So that works out well. But it is hard finding the time. And yeah, I'm just gonna wait for his review tomorrow stuff, and then I'm gonna make my notes and probably take it Wednesday.
Yeah.
yeah, I'm thinking to take it Wednesday morning because I don't work until 12 that day, so I have like
Nice.
a nice little chunk of time before that.
Yeah, absolutely. So you're gonna do the collect the data sheet for it? Awesome.
Yeah.
So I'm going to do what you just did, Nancy, regarding the breakdown. So that once it's there, you can just pick it up, right, Chase?
Mm-hmm.
Okay.
Actually, how did you send it?
I just sent it as an attachment. It's not a OneDrive
Oh,
file.
it's not one thing. So then I need to send
Sorry.
it to you. Okay.
Yeah,
Yeah.
I'm
You guys want to
sorry.
each
I wasn't sure if we wanted to use that, so I was like, okay.
No, that's good. I think it's great. So I'll update it and then I'll send it to you, Chase.
Okay. That sounds good. And then all this was recorded for Donna, so I'll go ahead and end it, and then we'll make sure that she can look at it if she needs it.
Okay.
Awesome.
Did we want to meet again or no? Or